All right, we are looking at the second half of section P.2 for college algebra. It's just a quick review of scientific notation. Our format when we write something in scientific notation looks like this. All right, a times 10 to the nth power. We do have a couple restrictions on that. That front number a, its absolute value, or the positive version of it, has to be greater than or equal to 1, but less than 10. In other words, there can only be one number in front of our decimal point, or to the left of that decimal point. The other restriction is that our power of 10 must be an integer. We can't have fractions and things like that. All right, so converting from scientific notation into decimal notation. If you have a positive exponent, that means that you are going to have a larger number. All right, your decimal is going to move to the right. So 6.2 times 10 to the 7th, when we multiply by 10 and another 10 and another 10, 7 tens means our decimal is going to go from 6.2 and we're going to move it 7 places that direction. So from here, it's going to move 7 spots. So we really are going to have a 6 and a 2, and since we use up one move just getting beyond the 2, we only need 6 more zeros after that. Putting in commas after each 3, we have 62 million. All right, the second one, same idea. It's negative 6.2 times 10 to the 7th. So the decimal is going to move the same way. The only thing different here is that we have a negative 62. All right. If we have a negative exponent, it means we have to move to the left. So our number is going to get smaller. Okay, so we had 2.019 times 10 to the negative 3 means we need to move the decimal 3 places this way. So we're going to have one space used up getting past the 2, and then we need 2 more zeros. All right. Question D, we are moving 5 spaces to the left. So again, we're going to use up 1 to get beyond that 2. We would need 4 more zeros. All right, now we're going to do the reverse. We're going to take those large and tiny numbers and convert them into scientific notation. So we want to make sure there's only one digit before the decimal, so we want our decimal to land between that 3 and 4. We need to include any numbers after it, with the exception of all these n zeros. So we need 3.497 times 10 to a power, and that power is going to be determined by how many decimal places we have to move. So we have 3 here, 6, 9, 12, 13 to get around that 4. All right, and since it was a very large number to start with, our power is positive. Here we have a very small number, so when we convert this, we are going to have times 10 to a negative value. We also have a negative out front, and our decimal, if we only have one digit before the decimal, we need it after this 5. So 5.012. And then how many spaces do we move? 1, 2, 3, 4, 5, 6, 7. So it would be times 10 to the negative 7. All right, let's look at doing some operations, multiplying, dividing, that type of thing, with numbers that are in scientific notation. First thing to notice is that we can multiply those 2 front pieces. The 6.1, we can multiply it with the 4. We will get 24.4. And then we have like bases. We have 10 to the 5th and 10 to the negative 9th. So we can combine those just like we did yesterday. We can add those exponents. 5 plus negative 9 would be negative 4. However, this one is not in scientific notation because that 24 is too big. Our front number has to be greater than or equal to 1 but smaller than 10. So we really need to convert this and move our decimal back here, one space. We want this to be 2.44. So now we have to decide, does that mean our exponent goes from -4 to -3, or does it become a -5? Let's think about what we had to do originally. Originally, it was 24.4, and we were supposed to move it from here 4 places to the left. So 1, 2, 3, 4. But if we already moved the decimal 1 space to the left, we really only need 3 more moves. So we are going to have a -3 as our exponent. Following that same idea with question H here, we can divide those front numbers. 1.8 divided by 3 would be 0.6. And then we can do the same thing we were doing yesterday with our common base. We subtract the exponents when it's a division question. 10 to the 4th divided by 10 to the -2, we would subtract 4 minus -2 is +6. But once again, this is not in scientific notation. That 0.6, the decimal's in the wrong spot. It needs to be 6. And if you want to put the 0.0, you certainly can. Now, do we move that 6 to become a 5 or a 7? Well, originally we had 0.6 times 10 to the 6th, which means from here we had to move 6 places that way. But we've already moved 1 spot, so we only need 5 more moves to make that equivalent. Go ahead and pause the video and try the next 2 examples. All right. Let's double check. 5.1 times 3 would be 15.3. Combining our 10s, we have -8 and -4. That would be 10 to the -12. Once again, converting this back into proper scientific notation, we need to write that as 1.53 times 10, and then checking our total direction here. We are going 12 units to the 12 spaces to the left, so we're going 12 this way. But we've already moved 1 space, so we only need 11 more moves to the left. And for J, 7.5 divided by 2.5 gives us a nice 3, so we are good with that portion of our scientific notation. We have 10 to the -2 divided by 10 to the 6th, which is going to give us 10 to the -2 minus 6, or -8. All right, our last example. It says in December of 2011, the U.S. population was 312 million and the national debt was 15.2 trillion. Express both of those in scientific notation and then determine how much each person would need to pay to get rid of the debt. So, first question, we have 312 million. All right, in millions, that means we have 6 zeros. So this is equivalent to 312 million, and converting to scientific notation, we would want that decimal to land between the 3 and the 1 here. So we want this to be 3.12 times 10 to the 3, 6, 7, 8. All right, the other number was 15.2 trillion, and trillion has 12 zeros. So we have 15.2 times 10 to the 12th, but converting that into proper notation would be 1.52 times 10 to the 13th. All right, then the second part of the question says, determine how much each person would need to pay to get rid of the debt. So we need to take the total debt, which is this, and divide it by the number of people. All right, so we have 1.52 times 10 to the 13th, and we are going to divide by 3.12 times 10 to the 8th. Once again, treating just the front numbers, 1.52 divided by 3.12 is 0.487. Subtracting our exponents gives us 10 to the 5th. We need to move our decimal 5 places that way, which means if we're going to keep this in scientific notation, we would have 4.87. We've moved 1 space here, which means we only need 4 more. If we wanted to put it in terms that seem more logical when we're talking about money, we could go ahead and move the 5 original spaces here, and we have 487 $48,700. Each person, every single person would need to pay that to get rid of our debt. All right, so assignment for part 2, page 33, 65 to 99 odds and question 115.